So this is the third part of the backup system, and I showed you the principles of what I wanted to design, and I think I will jump to the first design that I had. I hope it will not be too complicated. What you see here is this is the operational amplifier. It gets electricity and ground, um, and then it have one leg at 12 volt, and it compares this leg of 12 volt to whatever, just forget about this sign for now, whatever you have at home. You see, this is the entrance from home. And whatever you have at home, if you have at home 0, it senses that 3 is bigger than 2, which 2 is at home, and it's 0. So it triggers by a transistor, with the help of a transistor, this relay. The diode protects the circuitry because whenever there is a change uh, in coils, a change in voltage or cut in the current in the coil, whenever you turn it on or off, there is a big spike of voltage. By the way, because I did some review of a Joule Thief, the Joule Thief circuit, it takes a small battery that cannot run a LED, that a LED needs at least 1.7 volt, and the small battery, AA battery, is 1.5 volt, and if it's depleted to 0.8 volt, it still can run the LED, which needs 1.7 volts, I remind you. So how can it be? Because there is a circuitry inside that cuts the electricity, cuts the voltage every time, change the fill a capacitor and cut it, fill a capacitor and cut the connection to the diode, and this makes spikes at around 18 kilo hertz, many spikes that our eye cannot detect the blinking and the LED lights. So here the Joule Thief, the spikes are helpful, but here the spikes, because there is a coil and the Joule Thief has a coil also. So there is a coil. This spike can ruin the transistor or the whole circuit, because if it works at 12 volt, the spikes can jump up to 70 or 80 volt easily, and this will ruin the other circuit. So this diode helps the spike that starts from here shortcut itself directly to the coil and not jump to the other lines. So whenever, if we come back, whenever this operation amplifier detects that the home doesn't have voltage, it will energize a transistor that will energize a relay. That relay will close this connection, and this connection takes this 12 volt from the battery. This is the backup battery. You see 12 volt here in double rows, it's the backup battery. So whenever you see this double row, this is the backup battery. It takes it, connects it by this small flange that moves with the magnetic field, connects it and put it back to home. But what is the problem over here? And on the way, because it energizes the relay, it will light an LED, and this is a current limiter resistor. So the LED will not burn through 12 volt, it needs current limiting of 1K. So simple, should work, no? This goes down, home goes down, the operation amplifier start a relay, and the relay connects the battery to home. But what happens now? Now at home we have 12 volt from the battery as we ordered. But so the operational amplifier now not detect, it doesn't detect a fault. It detects that the home has 12 volt supply. So it disconnects the relay. So once it disconnects the relay, this flange goes to the side and there is no electricity at home. There is no electricity at home. So the operational amplifier detects no electricity and now it does connect the relay again and so on and so forth. This circuit will fluctuate between on and off all the time. And of course, it ruins the relay and it ruins the appliances at home. Appliances doesn't meant to work on and off 50 times a second. It depends. The speed is depends on the relay spring and this mechanism. It doesn't supposed to work like this. So this generally this circuit, and I'm not getting into this regulator and this potentiometer. It helps to just justify something and regulate some voltage, but it doesn't help to fix this main problem. And once I got into this, after I did the circuit and made a PCB, I I found out that there is a problem over here. And after I fixed something with these two components, I found that what happens if there is not at all, this circuit will not be connected at all, just disconnected from home. It can happen. It can happen. You want to test it, and before you connect it to home, you just leave it the contact open. So the same happens as if it was connected, because if it's not connected, it senses zero, it energizes the relay does connect it, and again, even though there are no appliances at all and nothing, none of the home circuitry and rails are connected, even though the feedback comes from this line, and again it sees 12 volt and then disconnect the relay, and this disconnects it, since there is no electricity and so on and so forth. So this was the straw that broke the camel's back. Of course, I cannot keep this circuit, even though when connected to whom it could work, not ideally, but it could work. But without connecting to home, it is a disaster. So that's why I went and designed another circuit, and it is over here. Now this worked with the breadboard sitting on the main 3 battery pack for a week, and I saw and I found it good. But to tell you that is the perfect circuit, I'm not telling you. You can take it and use it on your own risk. But for me, and I will be wiser within a half a year or 1 year of usage, and still for now, I found a small bug, not so small, but not so big. There is a bug over here, but this is much better. What you see here in the schematic, This is only an overview of what happens here. This is the same operational amplifier. Let's see if I can make it bigger, oh, but not too big. This is too big. This is too big. So, but I think that we can see what's going on. So this is the same TL084 operational amplifier, and but now it's not connected and used as a comparator, what is bigger and less, but as a comparator and amplifier together. You see this feedback resistor, it was not over here. There is no feedback resistor. There is just plus and minus. But here there is plus and minus and a feedback resistor. This feedback resistor, if you have at point 3, at leg 3, some voltage, and on the result, which is sometimes up or low, there is a voltage also, sometimes the highest, which is for here 12 volt, or sometimes 0. That's this is what the changes are from 12 to 0 if there is no feedback resistor. But if there is feedback resistor, this 12 volt connects to this middle of these two resistors, which are not equal. This is 2K and this is 15 kilo ohm, and it changes the entrance of this plus as a comparator now. So once it's up, it's not 12 volt here, but something in between. And once it's low, it's not 0 here, but something in between. I did the calculation, which is very simple, straightforward. I will not get into that now. And with this calculation, you can understand, you can find 2 points which disconnect at about 9.4 and connect at about 10.4, something, or 10.7. So this is just a minute, some reminder to me. So there are 2 points over here. If the voltage drops below 9.4 volt, please energize the relay. And I will show you what is going on here in a minute. And while the battery is going up and up and up, and while it's reaching 10.7 volts, around 10.7 volts, turn it on again and feed the home. If the home, I'm sorry, if the no, just a minute, I'm sorry, this will disconnect the battery if it's too low. So if it's 9.4 volt, which is low, disconnect the home while the battery backup is running. And if the battery is full more than 10.7, it will connect the home. Okay, I'm sorry. So after the battery is back again at 10.7 volt, connect it, and all this circuit is while the battery is running, which means we need to be connected to the battery. I will show you the other side of the circuit and you will understand more. This is a FET transistor that energizes the relay. And it says like this: when the battery is low, this, let's start like this. When the battery is high, connect this by this FET transistor, the relay. I'm sorry, don't do, if the battery is high, don't do nothing and the relay will be connected. You see, this is 12 volt, this is the backup. I'm sorry, this is the mains. This point is the mains, the energy at home, and and this is home. If everything is, let's see, just a minute. I don't want to mix something. Okay, if I'm not wrong, it works, but the stuff with the relay doesn't not sit very sharp at my head right now. But generally, if there is a necessity for backup and the battery is okay, connect this, energize the relay. No, the relay will be I think this is not a correct circuit. This is not a correct circuit because whenever the there is a battery necessity and the relay is energy and the battery is okay, don't do anything and just catch it by heart. And the backup will be flowing by the relay, the normally closed flange to home. But whenever the battery is too low, disconnect the backup. This is not very clear what is illustrated here. Disconnect whenever it's low, disconnect the backup from home. Now, this circuit, and later on, I hope I have time, I will uh, explain what is going on over here. Now, this circuit says this. Whenever there is electricity at home, energize energize the add another relay, 100 ampere relay, and connect this flange to up. Whenever there is electricity, it will connect from this point to this point, and home will get electricity because this mains. Whenever the mains is falling, there is no option to energize. There is no electricity here. So the relay with this spring rests on the battery backup, and nothing energizes the relay, so the flange falls down and the battery backup energizes the home. So only whenever the mains is on, this spring is lifted, is pulled up with a small force so that the the main will supply voltage to home. And again, if the mains falls, the relay doesn't have any supply, not energized, and the flange falls by itself. And from that moment, the battery backup, you see, backup battery will supply voltage to home. Now, before I try to solve to go again to this circuit, I wanted to make a comparison between voltages with hysteresis, whatever I did here. Now, this comparison, you cannot use the same battery for a comparison because if the battery falls, then it cannot sense upper voltage. For example, the battery falls, I wanted to disconnect at 9.4 volt. And if the battery is 5 volt, falls to 7 or 9 volt, it will not sense upper voltage. It cannot serve more than it can supply. For this reason, I used another 3 batteries 18650, which I scavenged from a laptop. And whenever there are at standby, it will not deplete because the backup battery will always on one direction with this diode will fill it, will make it topped. It will make it 12 volt all the time, and only whenever the it will always make it at the top position, so it can energize the operation amplifier in a 12 volt manner, and this can decide whenever to disconnect at 9.4 and connect at 10.7. Now let's go back again to this circuit. This circuit is running only whenever this flange is down and the backup battery is on. Whenever this backup battery is on, only it works if the voltage is above 9.4 volt. If it's below, it disconnects. So if it's below, this it energizes, it gives a pulse to the FET transistor. This energizes the relay, and the relay, this is not a correct circuit. The relay disconnect the backup. Disconnect the backup from the mains, and just leave it unconnected. I'm not sure if it's it disconnect and connect it back to the mains. It says if it's not connected, let's give it back to the mains. So maybe this schematic, this illustration is okay. Whenever we have here energy, the relay energizes. Whenever it's not energized, the battery backup, this is not correct. The battery, it's not energized. The battery backup is resting over this flange and connects to the home. It's not correct over here. Please excuse my schematic over here. And whenever the battery is too low, disconnect home from the battery. Now, I told you at the beginning that there is a bug. The bug is if it passes like 12 hours and the backup while running on backup battery, and the battery is disconnected, it's less than 9.4 volt. It's disconnected now. This small 18650 batteries should energize the relay, and it energizes again and again until it depletes, because the battery itself depletes, and after 12 15 hours these batteries, while energizing, it depletes. They deplete much they are depleted much faster, and they are falling. And when they are falling, it will connect, it cannot any longer disconnect the battery, the backup battery from home, because the backup battery is too low, and it falls, and the backup battery will connect to the, even though it's like 7 volt, it will connect to home appliances. And that's a bug, because after a long time, for short time, if for 1 hour, 2 hours, it can hold the backup without any problem and disconnect the depleted battery. This is only if the battery is depleted. But after this, it will no longer energize the relay, and the battery, the backup battery will be connected to home. So that's a problem that I have to think, what if I will use this circuit, if I have to fix it somehow, or if I want to only on certain circuits at my home where it's not suitable for low voltage. For example, they have a relay also. It's not suitable because the relay will not be energized and disconnects and then connects and disconnects whenever it has some energy. It will connect. Whenever it doesn't have energy, it disconnect and it fluctuates. So for this kind of circuits, maybe I should have their own voltage protection. If not, I have to think about other design, and from this one, from the first design, let's, where is it? So from from this first design, I came back to this one, which could work but had a big bug, to this third one, which is much better but have long-term bug. So this is an improvement, and you cannot jump to the highest level from first floor. You just climb step by step, and I'm uh, quite satisfied from this circuit. I worked all day to put it on a breadboard. This operation amplifier is very, very delicate. Any stray voltage, something that it senses from I don't know where, it grips and takes it to account and makes changes. I have to make the PCB very, very delicate. And another thing I found that it cannot sense more voltage than it gets a supply. If it gets supply of 12 volt, like we give here, it cannot sense uh, the battery. Uh, it's hard for it to disconnect at 10 and connect at 1 or disconnect at 10.5 with other circuitry of other resistors, disconnected 10.5 and connected 11.5. This doesn't hardly work because the batteries are 11 volts. They are not even 12 volts. They are 3 times 3.7 volt. Each battery of 18650 is 3.7 volts times 3, it's 11.1 volt. So just a minute. Okay, I'm back. So what I say here, I cannot really turn off the battery at 10 volt if this backup battery that supply the voltage for the decision maker operation amplifier is less than, is around 10 volt by itself. That's how it was. That's what I, first it started to work and then it didn't work. It made me, I lost a lot of hours understanding why it's sometimes working and sometimes not working. So the compromise is to use this 11.1 volts more or less if it's full, and disconnect the battery at 9.4 volt, which it's not ideal. I would have preferred to disconnect it at 10.5 volt or at 10.3 volt. But that's a compromise, and this is what this circuit did and do. And on the way, I added two LEDs here. This LED show that the low battery, there is low battery, and which means that the operational amplifier gives a high voltage here, and this is dual dual color. You see, it means it blinks. It dual color flashing LED. It blinks here, and only when we are running, only whenever the battery is very low and we are disconnected from the backup. The backup battery is not connected to home. And whenever we are resting and the battery backup is just resting and the battery is full, this LED lights, it's green light, and if I want to save energy for these batteries, I have a push button or a normally close switch. I can open it and this LED will not light, and it will use only 1.89 milliampere, which is very little. It can last about 1,500 hours without recharging, and with recharging it's much more than this. So these are why I added these two switches. So I hope you understood something from all this circuit. Thank you for watching.